Hello everyone, welcome to Chemizon Complete Chemistry. So in today's video, we are going to solve this question of JAM 2011 paper, which is based on hybridization in organic compounds. So if you have seen my video that I had posted on hybridization in organic compounds, you can easily solve this question. Now these are the four molecules that are given. We know oxygen has how many lone pairs? Two lone pairs, right? So if you compare all of these structures with the basic structure of, let's say, water molecule, okay, water molecule also has how many lone pairs? Two lone pairs. Oxygen has two lone pairs, and then there are two hydrogen. So you might say the hybridization is sp3, and you will mark for all the oxygen hybridization is sp3. So that answer would be incorrect. Okay, there is no such option available. So what we have to consider is, while finding out the hybridization for organic compounds, is you have to consider resonance. So what is the formula for hybridization? For finding out hybridization, or you can say steric number in organic compounds, it is number of sigma bonds plus the number of lone pairs not involved in resonance. Very important. Not involved in resonance. Okay, so why I'm telling this, let us first understand with some other example. Let's say I take this example of acetic acid, CH3C double bond OOH. Suppose I tell you to find out the hybridization of this oxygen, then you might say that there are two bond pairs and two lone pairs. Hybridization is sp3. That will be incorrect. Why? Because one of the lone pairs here, it is involved in resonance with this carbonyl group. So what we will get is that it forms what? It forms a pi bond, and we know we don't count pi bond while calculating the steric number or finding out hybridization. Okay, so this is a pi bond, right? That we don't count. So in general structure without pi bond, we say that this lone pair which is involved in resonance, that will not contribute to the hybridization. So there are total 1 sigma, 2 sigma and 1 lone pair. So total steric number will be 3. Okay, 2 sigma bond plus 1 lone pair, 3. So the hybridization is sp2. Okay, by using this formula, if you get the answer as 3, hybridization is sp2. If you get the answer as 2, the hybridization will be sp. If you get the answer as 4, hybridization will be sp3. Okay, so now let us see for all the structures. The first one, here you can see this lone pair is involved in resonance, so we will not count this lone pair. So we will count only one lone pair, 1 sigma bond and 1 sigma. 2 sigma plus 1 lone pair, steric number is 3, so this will be sp2. A second structure, again here this lone pair is involved in resonance. So again 1 lone pair and 2 sigma bond, total steric number is 3. So this will also be sp2. Now here this structure, you can see here there are sp3 hybridized carbons. Okay, we want a planar structure like sp2 hybridized carbon for resonance to take place. So here there will be no resonance in the third structure. Okay, so here there will be, we will count both the lone pairs here. Okay, 1, 2, 3 and 4. 2 lone pair, 2 sigma bond, total it is 4. The answer is 4, so it will be sp3. Okay, last structure. Again here you can see this is what, this is a furan structure, furan ring. Okay, the lone pair is involved in resonance, so we will count this lone pair, will not count this lone pair. And then there are 2 sigma bonds, so total 3. So this will be sp2. So what is our correct answer? Correct answer will be sp2, sp2, sp3 and sp2. Okay, so answer is sp2, sp2, sp3 and sp2. So what is the correct answer for this question? Correct answer is option A. Okay, I hope you have understood the solution. I will provide the link for the video which I had made earlier. In that we had solved so many examples and we have discussed in much more detail. You can watch that. Thank you.